everybody, I'm Miss Cooksey, and today we are talking about absolute value equations. It's going to feel like we're taking a sharp turn away from quadratic equations, but you'll see tomorrow how these really nicely connect. So we're going to go back to absolute value. Absolute value is a number's distance from zero, and when we graph absolute value, it is going to look like this lovely V-shaped graph. So before we talk about how we write an absolute value equation, let's look at what's called the parent function. Parent function means the most basic version of the function you can possibly do. For an absolute value equation, the parent function is f of x equals the absolute value of x. Let's look at what that evaluates to. So if x is 0, the absolute value of 0 is 0. That is, let's pick yellow. That is this point on the graph. When x is 1, the absolute value of 1 is 1. So that's this point on the graph. When x is negative 1, the absolute value of negative 1 is also positive 1. So that's this, that is a highlighter. Whoops. That's this point on the graph. And when x is negative 2, the absolute value of negative 2 is 2, and the absolute value of positive 2 is 2. So you can see kind of how we get this V-shaped graph. As we make all of these numbers positive, it becomes the shape of a V. But we want to go beyond the parent function. We want to look at a more complicated function. So this is going to be the formula for an absolute value equation in vertex form. Let's break down each of these pieces. The first piece we're going to break down is a. We actually already know what a does from our quadratic function in standard form. A is going to be what helps us figure out the shape of, in this case, not a parabola, but a V. So when a is, the absolute value of a is greater than 1, the graph stretches. It's going to get narrower, which we saw with quadratics. When a, the absolute value of a is between 0 and 1, when it's a decimal or a fraction, it is going to compress. It's going to get wider. So we're going to see a wider V. So let's draw narrow V, wide V. That should be in black. Narrow V, wide V, kind of like a bird. When a is negative, it is going to reflect over the x-axis. That means our V is going to be upside down. Next, let's look at what is going to happen with the h and k. HK is the vertex. So remember, the vertex is the topmost or bottommost point of our function. It means the same for an absolute value function as it does for a quadratic. To find the vertex, h is going to be the x-coordinate of the vertex. It is also going to tell us the horizontal translation from the parent function. So here, our vertex is at 0, 0. If h was 2, we would slide this over 2 units, and the new x-coordinate would be 2. What's tricky, however, is that there's a minus sign here. That tells us we have to change the sign. If this said x minus 2, the horizontal translation is actually a positive 2. With k, it works the same way. It's a vertical translation. Here, because we have a plus k, we do not have to change the sign. So if k was 2, this would tell us we have to slide up 2. This will make sense when we see some examples. So let's take this information and we're going to look at 3 examples. Can I make my face smaller? Ooh, I can. That's as small as my face will go, so we'll keep going with that. So here we have f of x equals negative x minus 2. Well, let's remember we have a x minus h plus k. So the a value here is negative 1. H is going to be positive 2 because we changed the sign because of that subtraction. And we don't see a k, but that means we have a secret plus 0 at the end. So our vertex is going to be positive 2, 0. The transformation here is that we are going to have a vertical reflection and we are going to move right 2 units. This -2 tells us we move right 2 units. It's always the opposite of what you would expect for the h value. If we want to see what this looks like as a graph, we reflected vertically and we moved right 2 units from the parent function. So the parent function was a perfect v starting at 0, 0. Now we've reflected and we slid right 2 units. In our next function, let's find the vertex. Well, nothing's being added or subtracted to x, so that coordinate's 0. My y coordinate is -1. I don't have to change the sign there because it's a plus k. So here, our transformation is going to be a vertical stretch, and it is going to shift down 1 unit. Let's see what that looks like. It is a narrower graph, and we have shifted down 1 unit from the parent function. Last but not least, we have x plus 2 plus 1. Our vertex is going to be hk. It looks like 2, 1, but we always have to change the sign of the x, so it's going to be -2, 1. There is no a value to change the shape of the graph, so we're going to shift left 2 units, up 1 unit. Here is our graph. Thanks for watching. I hope this video is helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.